Another example representation of this idea of adding and subtracting integers or positive and negative numbers are with what's called two-color counters. Sometimes they're called integer chips. And the virtual manipulative just kind of looks like this. We have red chips and yellow chips. And while these are just two-colored counters, meaning that they're just, and you can flip, I don't know what that meant, that one does. That literally on one side of the counter is red, on the other side of the counter is yellow. And so one way we can use these two colored chips is to think about the yellow ones as positive numbers and the red ones as negative numbers. So if we wanted to create numbers here, we can. And if we think about the yellow being positive numbers, then what we can do is think about the yellow as negative numbers. So we can start seeing that with one positive and one negative, they can sum to zero. We're not going to say cancel out because cancel is not a mathematical operation. They sum to zero, right? Positive one and negative one, positive one plus a negative one sums to zero, adds to zero. And so that's what's happening in here. We can explore by just clicking chips. And so we can see our sum is automatically updating the more chips we pull out. And I can pull out chips one at a time, the yellow ones, the positive ones, or the negative. And now we see as soon as I pulled in the negative here, my sum decreased by 1. And now it says my sum or my total here is 3. And what I want you to start exploring is this notion of a zero pair. A zero pair is one positive and one negative, meaning they sum to 0. Right? Again, we're not going to say cancel out because that's not a mathematical operation. But as I add negatives, what's happening to my sum? It's decreasing. As I take away negatives, now you can see my sum is increasing. And so this, right, think about the two verbs I just used. Add, obviously is our addition operation, but take away. What operation is that if I'm taking away? And so that interpretation of take away, right here, I'm adding. So here my sum, I can keep my sum. Let's see, what do we want our sum to be? We can sum 5 and then we can add a -1. So 5 plus a -1 gives us our -4. 5 plus -2 gives us a +3. 5 plus a -3 gives us a +2. 5 plus a -4 gives us a +1. 5 plus a -5, right? 5 plus a -5 sums to 0. We can keep adding more. 5 plus a -7, right? Helps us go all the way to -2. And again, we can compare that back to our number line. I'm sorry, this wasn't cleared out. But this is the power of the idea of multiple representations. So if we had a +5, right? What did we say? We had a +5, and now we were adding a -7. So we're starting at +5, and we're not going 5, but we're going a -7. Boom, brings us down here to -2. So I want you to see how this representation with the chips can translate to this representation on the number line. So, and I want you to start getting comfortable with chips. And here are also the instructions. It says, drag +1 chips and -1 chips into the modeling area that's here. Watch the sum update. To remove a zero pair, right, drag on a positive or a negative on top of the other one. You can go either way, right? So again, what you might have thought of before this moment as canceling out, they're not canceling out, they're summing to 0. A +1 and a -1 sums to 0. So, and 0 is known as the additive identity, right? If we add 0 to this sum, right, to this total, -2, -2 plus 0 is still -2. And so that's what we can show here with this idea of zero pairs. -2 plus 0. -2 plus 0 plus 0 plus 0, right? We're adding 1 and taking 1 away at the same time. So that's a 0. See, my sum didn't change even though I added all of these chips to my mat. So this notion of 0 pairs is how we're going to help to explore especially subtraction with the integer chips, or with the two colored counters. So let's think. I want a new one. So here, 6 minus a -2. So first it says model 6 by dragging the chips into the modeling area. So 1, 2, 3, 4, 5, 6. It can even keep count for you here. And now, but if we think of subtraction as take away, I want to think of minus a -2, meaning to take away -2 chips. However, I don't have any chips here to take away. So what I can do though is add my 0 pairs, because that's not going to change my total, right? Here, even though I have 7 positive chips and 1 negative chip, I have my value here is still only 6 because of this 0 pair. And I can make another 0 pair. Again, I just added 0 to my first number that I'm adding to be able to model this situation or represent this situation. So now I have 6 positives plus, well, 8 positives, but I have these 2 0 pairs here at the top. So now if I'm thinking about 6 minus a -2, well, here's my -2. I want to take away a -2. Oh, sorry, I wasn't following the directions. This says model. We can even follow the directions. Model 6 and then hit continue. Now subtract 2 by removing chips. You may have to add some 0 pairs first. So if that 0 pairs thing didn't make sense, right here it tells me I want to take away this two negatives. I don't have any negatives. So I need to add a 0 pair and a 0 pair. And now subtract drags chips here. Take 1 away, take another 1 away, and now click continue. And now we can see 6 take away -2 leaves us with 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. And you can check your work and practice that. So do that a couple of times. You can follow the prompts and start to make sense of what's happening here. So now I want us to think about that same problem, the 6 minus the -2 being a positive 8. And how does that translate to the number line? If we're thinking of counting backwards for subtraction and counting forwards for addition, how in the world can we conceptualize what it means to subtract a negative? And so that's a really, really, really important piece. And so if we think about it, right, if we want a 6 with a -2, right, this is what we have. But if we are thinking about 6 and then -2 here, this is showing 6 plus a -2, right? We're going backwards to 4, or just 6 minus 2. So how would we know that we want to take away these 2 negatives? And this is why I like this representation, right? If we think about subtraction as take away, and so here, if we have 6 and we're taking away these negatives, that's how it's getting more positive, right? We're taking away the negatives. Another analogy that some have used is this idea of, like, if you put ice into a drink, the more ice you put, the colder it gets, right? The temperature is decreasing. But if you take ice out, right, we're taking out the negatives. And then so the temperature would be increasing is one way to think about this idea of positives and negatives. But what I'd like you to think about is the way we're facing on the number line and then the way we're walking on the number line. And the next video is going to explain this in more detail. And this way, because it's limited, if we picture a little guy standing here on our number line, see if I can draw, right? If he walks forward, right, if we're adding adding a positive number, we can walk forward and faces forward. If he's subtracting, right here, this is our 6 minus 2. We can think about this as 6, and then he can take, he can walk backwards 2. So we're going to use this notion of facing one way and then walking one way. So we're going to face forward or backward, or then walk forward or backward. So here, if we're thinking about 6 minus 2, we can start at 6, and we can see this one as face and then backwards, right? If we're going to subtract, we're going to face backwards, and then with we're going to minus a positive 2, and then we're going to walk forward, right? Because the 2 itself is positive. And we're going to walk backwards then. We'll be facing this way. Here we go. I'll make his face. So he's facing this way, walking that way. So he's facing the negatives and walking then 2 steps forward to the negative to get to that 4. But now we can also think about this as 6 plus a negative 2. And if we have a 6 plus a negative 2, we can think about our little guy as facing forwards, right? He's facing this way, right? So he's facing towards the positives, the plus, but now he's going to walk backwards, right? His body's going to walk backwards this 2. And this notion of separating the operation and then the sign of the number is going to be really helpful for now when we think about, sorry, this looks ugly. Walk. When we think about 6 minus a negative 2. So here we go. How do we face if we're negative? So we're going to face in this negative direction. I'm going to erase this arrow too. We're going to face this way. But now we're also going to walk backwards. 1, 2, right? We're going to walk this way. And that's going to change where we land, right? So we, again, face with the either forwards or backwards, towards the negatives if it's subtraction, towards the positives if it's addition, and then the sign of the addend, the second addend or the subtrahend in this case. The first number is called the minuend, the second number is called the subtrahend. In this case, the subtrahend is negative, so we're going to face negative, right? This is where we face. This is the way we face. Sorry, that's C. And this is the direction in which we walk. So again, we're going to walk backwards because it's a negative 2. So we faced the negatives, but then we walked backwards, and that brought us up to a positive number. So this idea that 6 take away negative 2, right? We're taking away these negatives is the same as 6 plus 2.